Hello, everyone. I will talk today about developing Apache Airflow. Few words about myself. I'm Jarek Potiuk. I'm from Warsaw, from Poland. I'm an ex-Google tech lead manager. 10 years ago, I was at Google. I co-own a company, Polidea. I work as an engineer in that company as well. But for many years, I was CTO of the company. I grew it from like 6 to 60 people, from 6 to 60. But then I decided to come back to an engineering career, and I'm a principal software engineer in the company and work on Airflow. And as of a month or so, I'm an Apache Airflow committer. So I'm proud to be invited by the community to become committer. It just took half a year to get there, so it was a bit tough. And I've got more than 20 years of IT experience, as you can see from my hat. And I've been working on many different things. So Airflow is just last beloved project I'm working on. I worked on mobile backend with actually a few people who are sitting there 10 years ago. I've worked on mobile apps. Quite recently, I had a experience over a year working on the robotics and AI in a robotics AI startup. And I actually developed some games as well. So quite a versatile experience. A little bit of context, what I'm going to talk about. I'm going to talk about development environment for Airflow. And this development environment comes from the work we've done at Polidea. Polidea is the software house based in Warsaw in Poland. And we have a whole team working on Airflow. We have 65 people in total as a company. So only part of that is working on Airflow and cloud. So we have like 5 people working on Airflow. But we also work on mobile apps, embedded devices. So we develop firmware. And we have a whole team working on cloud, mostly on Google Cloud projects. The team was involved in Airflow since August 2018. That's where we started our engagement. And during that time, we developed more than 70 operators for 12 different services, Google Cloud Platform services. This is where our focus is. So, and we work as a team. So it's not like individual committers committing the code, but we have the whole team working together, which means that we have to have a quite good development environment for the team working together and developing all those operators. Because, that's the team. So we have Szymon also here. He will be speaking next. And we have 2 Apache committers now, myself and Kamil. We have project manager Karolina, Jarek and myself. We are also certified professional architects of Google Cloud, and Antek, who has done a terrific job on delivering actually most of the operators, I think. So that was basically what we focused on. So we focused on Airflow, talking to all the different properties or services of Google Cloud. And when we joined, the picture was a little bit smaller. There were just few services. Right now, we have all those services that that you see, and you can use operators which we developed for Airflow. But when we started to work with Airflow, we saw, especially that we had a team and those 70 operators to write. We saw how difficult it is to write new code for Airflow. It wasn't a nice experience for developers. So there were some frustrations of fresh developer experience that we had, and we've learned that there is a quite high learning curve and quite high friction at the very beginning when you start developing Airflow, in order to have the environment set and in order to be productive in what you do. And specifically, the iteration speed is very slow. I will show some examples a little bit later. And it has a little bit complicated development environment. It's not something that you can set up very easily in few minutes. It's something that literally took us days initially to figure out how to set up properly to be able to add new operators and test them properly. This was a fairly difficult thing. And if you haven't seen the Ash, probably most of the people who are committers or involved in Airflow, they know Ash from Astronomer. He prepared a presentation, a screencast, where in an hour he explained how he works with Airflow, how he develops. And if you look at it, this is like a fantastic resource for anyone who wants to learn how to develop Airflow. However, you can see how complicated it is, because you have to set up some manual variables, environment variables. You have to know how to run certain tests in order for them to succeed, etc., etc. So Ash is like master of that, but he's just Ash, and he works many years already, or months on Airflow. We wanted, so our idea was that we have to have something very easy to use for developers the first time they use Airflow. They start working on Airflow. So we focus on developer productivity. So for my 20 years of experience, developer productivity was something that recurs all the time. I've developed probably like 5 or 6 different development environments to make developer more productive. So that's the same with Airflow. We wanted to decrease the developer frustration, improve the teamwork, improve the way how the team works together. And we want to make it easy for ad hoc contributors to code and test the code. For Airflow, it's quite often we are, as committers, we are asking people, so somebody is asking for a new feature and we say, oh, maybe you can develop it yourself. Maybe you can make a PR. But if you are an ad hoc contributor, this is not very easy because you have to have all this environment set. So, one of the things that I've done during these 6 months is a number of improvements, so-called Airflow improvement proposals, which I proposed. It's quite, if you know Airflow or other Apache communities, adding new breaking features or like big features, it's a kind of long process. You have to write a proposal, you have to justify it, you have to convince others that it makes sense. So I started with the AIP10 multi-layered official Airflow image. It's been approved already, like there was voting. It's in progress. I implemented 2/3 of it right now, or the second commit is going to be merged, I hope tomorrow or the day after, or after I return back to Poland, because we are coming back tomorrow. And that was kind of prerequisite for the development environment. The whole idea was that we have a single image that we can use for continuous integration and for local development. And I built on top of that a simplified development workflow, which is another Airflow improvement proposal. This hasn't yet been voted. I just presented it on a dev list. Some people are craving for it. I would say that's what I've heard, some comments. But I want now to present it to the community what I've done and make a proposal later. Then, as a follow-up, that's something also that is built on top of that is AIP4 support for system tests for external tests. Because what we have done in our GCP work was automated system test, including the GCP. So we can run our operators through like the whole cycle of connecting to the Google Cloud Platform, seeing the results of it and making sure that it works with the actual real GCP. So we can run system tests automatically. And this improvement is targeting this so that you can run system tests with connecting to some external systems and make it easy for developers to do. This is not easy today, but in the future it might be. And that's a follow-up work. So a few words about the environments that you can use as a developer of Airflow. So first of all, you can use local virtual env. Yeah, so you can just install all the dependencies, have it running on your Mac, run the tests, and then you realize that you need some external dependencies because you need a database. You need to have the database set up. You need to have it reset and initialized. And probably you need Kerberos if you want to have some other tests to run and lots of other different stuff. So local virtual env is just very simple. It's super useful for like IDE so that you can have autocomplete and you can see all the dependencies, but there is not much you can do with that. There is a Docker image, which makes it even easier to set it up so that you don't have to fix your dependencies and make sure that they are installed because they are in the Docker image. But again, it has the same limitation of not having external systems. There is a Docker Compose already. the Docker Compose, which is now used to run the Travis CI tests. And you can have the same Docker Compose run locally, but it's surprisingly difficult to run tests. I will show in a moment how it works. And there is this, then you can have your own Travis fork and run all the tests in your pull request before they actually hit the main PR. So those are the test environments that you can, development environments that you can use. Oh, sorry. And what I'm focusing on with the simplified development environment is Docker Compose part. So you can have the same as in Travis CI, but locally on your machine and run it with all the dependencies. This is the whole idea. So what are the problems with the current Docker Compose test environment? The scripts are which run the tests. They are foreseen for CI scenario. So they run. They are good if you run the whole suite of tests, but they are not really foreseen for like running individual tests one by one or iterating with them. Dependencies are in, if you use the Docker Compose, which is now, every time you enter the Docker Compose environment, you have to reinstall all the dependencies from the scratch. They are not kept until they are reinstalled every time you re-enter the environment, and it takes a lot of time. For all the tests that you run using the ready-to-use scripts, always database is reset at the beginning of the test, which takes like 20-30 seconds. And then if you want to repeat running the test all the time, several times, that adds up. So it literally takes minutes to run the test if you start and you want to set up the environment, have it running, and run the test. So it's minutes to run the test is very long for the ad hoc developer for repeatable tests. And there is no guidance how to easily iterate with the test very fast. So that's the Ash's presentation, which I shown, that it has all the guidance, but then you have to watch a 1-hour talk and learn all the tricks if you want to really be efficient with the work. So the idea is really to make it so that you don't have to know the tricks, just you use the tricks automatically. How to run the tests in the current environment? So first of all, you run the Docker Compose. Easy to remember command, of course, how to run it. Yeah. First time you run it, it pulls all the images. It takes 5-7 minutes to pull all the images, which you cannot avoid anyway. Then when you run tests, then you use another very easy to remember command to run the tests, knowing which backend you're using, which Python version you use. And you have to remember to put this minus there to run the test. And yeah, well, okay, that's easy. Or you can enter the environment once and then run the tests, also remembering how the test is named. So you have to remember that the test is named like that. You have to remember that this test uses this colon in the middle. Exactly which colon is it? Where is it? That's PyTest. Yeah? So you don't really know. You don't really remember what to do. And what happens when you run tests? It looks like that. I made a screencast recording just to avoid demo gods. So this is what happens. This is 20 times speed. So it's very much sped up the way that happens when you first time enter the environment. So I can do that, and that's 20 times speed. So we want to run test. Yeah, that's what you want to do. And at the end, after this 7 minutes, it takes 7 minutes. If you run it just with the normal speed, you get this error because some dependency wasn't installed, and you have to do again. Yeah. So this is how the first time experience of the user, of the developer, looks like right now, pretty much. Yeah. Which is not very nice. So total time 7 minutes, running one test, failure at the end in this case, which happens quite often because our dependencies are kind of not, it's complex. I wouldn't go into details. When you rerun every time the test, it takes 10 to 20 seconds to reinitialize the database. When you re-enter the environment, you again install all the dependencies. That's kind of mind-boggling. And it's surprising. If you want to run the test that you remember you ran before, you have to again remember the whole command line that you used, because there's no history that, like, you enter the Docker and the history is gone, so you don't remember the test that you to run.
Docker cache not, remembering. Are we flushing the Docker cache? Or what's going on?
No, it's not. It's like it does not store the install dependencies as an image layer in Docker, so it's just install it every time when you enter. Don't ask me. It was like that implemented originally. There is no layer with installed dependencies. They are installed every time you enter the environment. Yes, that's exactly the point. Yes. So the ideal workflow, which I imagine as a longtime developer, you remember very easy command, breeze. And now coming to breeze, it's a breeze to develop Airflow. It's a nice wordplay. So we name the whole environment breeze. And then you would like to specify the backend and the version of Python to use. Yeah, that's easy. It would be nice if you run it and you have autocomplete of all the options. So you just type -b and then you tab and backend SQ. Then you type SQ and then tab and SQLite. All the normal thing that you would expect from a command line. Yeah? That would be really great if we can have something like that. Then you expect, when you rerun the test several times, you expect sub-second test execution overhead, not 20, 30 seconds to wait until you see the results of your test, or your test actually starting running, because then you can wait until the test is finished. Then you want to have sources mounted to the Docker container, so that when you modify it locally, you get it already in the Docker. This is already what is happening. The current environment, so that's good thing for the current environment. You probably want to have ports forwarded to the databases and web server, which is running inside, because you need to get somehow to the Docker environment, and sometimes you need to query the database or just connect to the web server. And you would like to have some help for developers who are ad hoc, how to run the test, how to debug this. So this is something that I would imagine as a development environment. Another nice feature that may be useful when you run tests, you just type run tests, start typing the test name, tap, and you get it auto-completed. Again, that's a very nice feature to have. Probably what you want to get is a bash history across sessions. Yeah, so you want to run the test that you ran for the last time. Another one thing that I found really necessary is, like, whenever there is a new dependency that you downloaded, because you just synchronized with the master version, the latest one, which like happens quite often, that the new commits are added. Then you want to know that you need to rebuild the image, and you get this image rebuilt automatically for you or pulled. And you would like to get an easy debugging. So yeah, you would like to get IDE, maybe IntelliJ. I love IntelliJ and I use it very, very much. And you would like to run the test and be able to debug from within. That's something that you would like. And here comes the breeze. It's exactly this. So this is something that we used internally first, but now we want to make it part of the Airflow core. So I have another video. This one is not sped up. It's just actual time of execution. So what happen, you just run breeze. It's already after pulling all the data. You have this autocomplete on the flags, and you're in the environment. That's it. No installation of dependencies. They are already there. Now you run tests. The first time you run the test, you do initialize the database. Yeah, okay, because it's you probably need to reinitialize the database quite often when you run the test, because you want to start with a clean state. So that's the first thing that happens. It takes a little bit of time, of course. Then you have the tests. They are running. Some of the tests are running a little bit longer, but they are running and they will finish. This is a video, by the way, so it will work. Now, now you have subsequent runs, and next time when you run the test, you probably want to get it sub-second overhead. So you run it, and yes, it started running. The database is not initialized, but you can initialize it with this additional flag if you pass this flag. I'll actually show it in a moment. Yeah, so that's what you when you run for the second time, it works this way, and you can repeat it continuously and get it as fast every time you try it. Now, test autocomplete. So you don't remember how your test was named, so you just start run test. Yeah. And then start your tests, whatever, hooks, tap, yeah, and you see all the tests you can run. There are plenty of them. And of course, yes, Druid, hook, whatever. And the colon there, yeah, because you have to remember that the colon is before the class name, not somewhere else. Yeah, works like magic. Then you can have a database initialization. So when you want to rerun your test with initializing a database, you just pass this with db init, and magically the database will be cleaned up before your test, which is pretty useful. And of course, just by the way, this with db init is also auto-completable. So if you ask, so this works really nicely. And this is. So that's how this works. Then we are exiting, and there are some other things. So there are hints for developer as well. So when you run Breeze, you get some information printed, which might be actually useful for first-time developer. The logo, of course. Then you have all the versions, version information, which version you're running, which user, which backend. Then you have some additional comments that you can use very easily. Information how to add Breeze to the path. And by the way, the information is gone if you actually did this before, so it will not be printed. Then you have a port forwarding information, so you see to which port you can forward. Then you can set up autocomplete in like one command, of course. And then you can disable all these cheat sheets with one command as well. And at the end, you can also see exactly how to debug your code with IPDB, which is part of the installed dependencies. Yeah, so that's how you run the test, and you know how to do that. So first-time developer doesn't have to read it somewhere in README, or nobody reads README anymore. Yeah, and that's what I've learned recently, that nobody does it. Okay, so that's just a glimpse of what Breeze is. There is actually, that's the next step. So, sorry, what's this? Okay, so there is 10 minutes screencast, which I recorded, which is part of Breeze onboarding documentation in contributing, and that hopefully will go there as well. So you can see more features there. It's 10 minutes, and it actually shows you that you can get the whole environment from 0 to running tests in 8 minutes. So that's how long it takes to get the whole Breeze locally running. When it's going to be ready, hopefully soon. Today I'm talking to the community. This will be recorded. Maybe that will be used for like spreading the word a little bit, because I've learned that you just cannot drop things at the community. You just have to explain and get the buy-in. I hope I will get it soon. There is prerequisite, this Docker image. I'm merging second commit, and I need the third one, and have the tests running automatically using my image. That will be next few days, hopefully. Depends how much time I have for that. Because I have a few remaining tests in the Travis CI. I hope soon we will start proposal voting for this AIP proposal. And finally, we'll get per tier merge. And I've already worked a lot with Ash and Foco and a number of other committers. So hopefully we can get this merged fairly quickly. That's about it. Thank you. Any questions? Yes.
So what you are like contributing, is it a Docker image made out of multiple Docker images?
Okay. So the question was whether I'm contributing Docker image made of several images. This is a single Docker Docker file, which contains several different stages. So, and we are using the multi-staging feature of Docker, which allows you to dynamically create different kinds of Dockers from the same image, for example. So from the same Docker file. So in this case, there is a Docker file which can be used to create an official CI build, without CI dependencies. And in the future, the same build will be used. That's a follow-up that I'm also going to work on. One image that will replace the Puckle Docker. If somebody is familiar with the official one that people are actually not official. It's an image that people are using in production. So, but this image is not optimized currently for running in production. It has a number of features to optimize it for actual build time, not the execution time of Airflow. So in the future, we will make it official image of for replacing Pukel, hopefully, because it's not really maintained that well. Yeah.
Cool, thanks.
Yep.
Really cool. I love the logo, by the way. So is this more for people that are trying to develop on Airflow, or is this for people that are trying to build DAGs?
This is more for people who want to develop new operators. So the question was, is it because for recording? So the question was whether it's for people who are developing DAGs or whether the people developing Airflow itself. This is more targeted for contributors who want to develop Airflow, add new operators, for example, or make some changes or fixes to the Airflow itself. However, we actually used it for testing DAGs. So in the future, when we get this like system test functionality in, the same functionality can be used to run your DAG through like the system test. We used that for our development because we had a number of example DAGs that we were using to testing our operators, and it's fairly possible and fairly useful to run it this way.
Is it all Bash and Docker files?
Yes. Yes, it's a Bash script, pretty much like a glorified Bash script. I found like a little bit of Python code as well, like generating the tests, list of tests is somehow XML parsing is done in Python to make it like real programming, not Bash. But yes, Bash is very good for that, for running these kind of environments. Yeah. Yes?
Here, first, I want to say this is fantastic. I think it might be a tougher problem to solve than actually what Airflow solves itself. Or maybe not. But it's definitely like non-trivial, right? To get these good development workflows. I really like the idea too of making it easier for people to test DAGs too, and that'd be really good, like next phase to this, or an extension or inspiration for that. My question is around like testing operators, like stubbing versus like having permanent infrastructure, like CI where you're actually talking to say BigQuery versus like having a really good like fake BigQuery client.
Mm-hmm.
Which way should we go with that? It's so hard to test against all these systems that don't really exist outside of the cloud. Okay,
so the question was more or like how to test external systems, whether to mock them or to test them.
Right, that's
yeah, so both. So we do both. So we stub and mock all the different parts, like hooks and operators at different levels. So all the automated tests that we run with GCP, they have lots of fakes or mocks, whatever you name them. However, we found it really useful to be able to run it against an external system that you actually communicate to, and that's not something that you have to do permanently or always. That's something that we automated. So we have in our own version of Breeze, which is a little bit different than this. We have a tool to be able to run full system tests from within the IDE. So you just click run on system test, which is a Python unit test, and run it, and it will communicate with the external system. And that's the part of the next improvement proposal. And hopefully, the idea is really to run it from time to time, not always, not with every pull request, for example, or not always. You can have some automation around like setting up the environment, running the test, and tearing it down. And this is something that we've done usually, like set up everything, run everything, and tear down. And actually, we even built it into the test itself. So our system tests, they have a setup mechanism that you can run automatically to set up the whole, like, for example, Google Cloud and Google Compute instance, run the test against that instance and tear it down. So this is how we solve the problem, actually.
And then follow-up question is like, so unit tests might be kind of daggy in some way, right? They might have dependency on each other.
Yes, they do actually now. Yes.
How about like using DAGs to test operator? Does that make any sense?
That's what we did.
Okay.
That's exactly what we did. So the question was like, how about using DAGs to test the operators? Yes, that's what we do. So we actually, it's even more, let's say, embedded, because we have our example DAGs for our operators that are not only used to run the whole test with the real GCP, to communicate with the real GCP and like starting the instance, setting it, shutting down, but they are also used as examples because the documentation of Airflow actually uses Sphinx and pieces of the code as are part of the documentation. So the documentation is always accurate because we have DAGs that are actually runnable, and the code from it is used as example. So this is like best of the use of DAGs, and you can just put it in example DAG folder and run it from the code. That's what we do. Any more questions?
So
Yes.
like what Max said, so will we have an option just to run it without the actual TCP or AWS accounts, just with the mocks?
Well, okay. So the question is whether we can use it with GCP without GCP or AWS, but just using mocks. That's entirely dependent on you. Most of the unit tests that are there in Airflow, they don't require external dependencies, except those like database, Kerberos, and few other things which are already part of the environment. The environment doesn't make any assumption. It's like purely generic. It's not GCP whatever, the one that we are committing right now. It's for general purpose, so it doesn't make any assumption about external systems at all. You don't need it, and depends how you write your tests. You can need you might write your tests so that you mock everything and run the hooks and operator tests automatically without any external dependency, or you can write your system tests in the way that they communicate with the actual external system. So you can do both, but it depends like on the tests that you write. And in our GCP code, actually you can look it up even now, like all the GCP operators that we developed, they have both types of tests. So they are unit tests for the operators, for the hooks, and then there are system tests for running with the actual GCP. And the system tests are not run automatically right now. They are skipped. So we made it so that they are skipped, but you can configure certain environment variables and run them, and then they will communicate with external system.
So to your question, I think there's also another layer of testing you can do on the DAGs. So think about you have unit tests. As you load the DAG, I understand probably it's about, where you inspect the arguments that see what those arguments are computed correctly. Also another even also, I think we talked about like unit testing, focusing on operators, and also like system testing on DAGs. I think there's also like one piece that we haven't touched on is like really help you be able to have better unit testing frameworks like DAGs.
Yeah. Okay. Thank you. I'm here. Yes, I'm here after the talk as well, so we can talk after that. Thanks.